This is Gail Kovac for Gresham Barlow School District. This is Summer School, High School Credit Recovery, Algebra 1A, and Learning Target number 12. I can solve systems of equations using substitution. So we just learned that a system of equations is where there are two lines or curves, and a solution to the system is where do they cross? What are values of x and y that work for both at the same time? So we learned how to find the solutions by graphing. You locate where the lines or whatever cross. But in this case, we're given just both equations. And I mean, we could make a big graph and actually graph those out. But gosh, I've got a y-intercept here of 23 and negative 16, that's 17. That's going to be such a huge graph. And then, sometimes I don't graph so accurately. There's got to be a better way to do this. And in this case, there is. Both of these systems are set up to solve using substitution. So in substitution, you're basically trying to mesh both of these equations together to make one equation, and then solve for x and solve for y. So we'll be using our algebra skills here. Now in this case, I have two equations that are y equals and y equals. Y is equal to 6x plus 23, but simultaneously, y is also equal to negative 2x minus 17. Now, if these things are both equal to y, they're both equal to the same thing, aren't they also equal to each other? Here is 6x plus 23. If that is also equal to y, and this is also equal to y, negative 2x minus 17, then they are in fact both equal to each other. Notice here that I have an equation with just one unknown. There are no more y's here. There are just x's, which means I can solve for x. I'm going to do inverse operations to the both sides to isolate the variable and figure out what x has to be. Now, I happen to have x's on both sides of the equation of the equal sign, so I'm going to have to move those over first, and I'm going to choose let me do this in red. I'm going to choose to add 2x here so that these ones will be gone and it'll just be x's on the right. And I need to do the same thing to this side. Notice that I'm adding it to the x component, not to the constant, because we're doing like terms here. Minus 2x and plus 2x means the x's are all gone. Let's see what I'm left with now. Okay, 2x plus, 6x plus 2 more x's gets me 8 x's altogether. Plus 23 is equal to negative 17. All right, so now I've got my x's just over on the left. Let's get rid of this constant of 23. I'm going to subtract it, and I'm going to do the same thing to both sides. Plus 23 and minus 23 are opposites and cancel. Let's see what I've got now. That 8x is still over here on the left. And now I've got negative 17, take away 23 more. That's a big negative number. That's negative 40 altogether. All right, now I just need to get rid of that coefficient of 8 out in front. That's 8 times x, so I'm going to divide by 8 on both sides. Times by 8 and divide by 8 are opposites and cancel. I'll have remaining x equal to negative 40 divided by 8, that's negative 5. Now, I've only found half of my answer. The question is, what's the solution to the system? It's where do the lines cross? Well, I know the x component. That's negative 5. However, I still need to find the y component of my answer. Oh my gosh, this problem's got a lot of work in it. Well, I happen to have two different options here for y. You can solve for y using this x here, or you can solve for y using this equation with x in it right here. You can pick one, substitute negative 5 in for x, and then you're done. So let's choose, negatives get kind of messy, so I'm going to just choose the top one. Really, it doesn't matter, you can choose either. But I'm going to say y is equal to 6 times x plus 23. And I'm going to use this answer of -5, and I'm going to put that in there, -5. All right, let's do some cleaning up here so I can figure out what y is. 6 times -5 is -30. Then there's plus 23. And -30 plus 23 that's -7. All right, so now I know what y is. It has to be -7. And gosh, that was a lot of work, but hey, at least I didn't have to graph it. That would have been a huge graph. I just had to solve a couple equations here, and there you go, -5, -7. Make that look more like a 7. There we go. So one way you can do substitution is this way. When they both happen to be equal to y, you can just set them equal to each other, and there you go. Now, this one's got a little bit of a problem. I've got y equals something of x here, but in this case, oh man, that doesn't say y equals. That says a whole bunch of other stuff. What can I do here? Well, I do have this part here. I know what y is in terms of x here, and ooh, here's my other y. I'm just going to put all that stuff in for y in my second equation right there. All right, let's rewrite that second equation. -3x minus 2 times y, and I know what y is in terms of x here now. That will equal 4. Instead of that y, I'm going to write what this top equation tells me that y is equal to. It's equal to all this stuff. It's equal to x plus 8. And now again, I've mashed both of these two equations together. I don't have any more y's. I have one equation with just one unknown, just x's. That means I can solve. So I want to set this up, but I notice I've got these parentheses with something out the front. I'm going to need to distribute that first. Let's take care of that first. All right, -2 is going to be multiplied to the x, and -2 is going to be multiplied to the 8. All right, let's clean this up and see what we got. -3x, -2 times x is -2x. -2 times 8 is -16. That will equal 4. And gosh, I still don't think that we're ready to solve this because I see two like terms on the same side. I can rewrite that as -3x minus 2 more x's. That's -5 x's all together. Whew, this is a lot of work, isn't it? All right, so now I think I'm ready to solve. Okay, I've got my x's here. Let's take care of the constant first. Get rid of that -16 with a +16. Let's be fair and do that to both sides. Those will cancel. Let's see what I'm left with here, my -5 x's. And let's see here, 4 plus 16 gets me 20 altogether. Now to get rid of that coefficient, multiply by -5, I'm going to divide by -5, make it go away. Make sure I do it to both sides. Times by -5 and divide by -5, boom, you are gone. Let's see what x is equal to. It is 20 divided by -5, that's -4. All right, I've got half of my answer. It's -4 for x, that's where those lines will cross. But what's the y component? I still need to figure that out. All right, well, I know I've got an equation for what y is in terms of x. And guess what? I know what x is now. It's -4. So let me just use this top equation. You could use the bottom one, but gosh, that's going to need a little bit more work to figure out what y is. This one's nice and clean and simple. Let's use that top one. Y will be equal to x plus 8. And what am I going to use for x? I'm going to use what I solved for right here, -4. That's going to go in there, -4. All right, let's see what I get now. Y is going to be negative 4 plus 8. That's going to be positive 4. So now I know my y component. Okay, that wasn't too much more work. 4. So if I were to graph these two lines, they would cross at negative 4, positive 4. Now, substitution, you're mashing the equations together. One of them should drop out. If they're both y equals, you can set them equal to each other. If you only have one y equals, then you can put that piece in for y wherever you see it in the other equation. This one needs a lot more cleaning up with distributing and combining like terms potentially, but eventually you're solving for x, and then you're going back in and you're solving for y to find your x and y coordinates of the point where the two lines cross.